Hi everyone, welcome back to another video. So we're going to be going through another kit today. Today we have the LED desktop rotating gyro kit. Here's what it kind of looks like when it's built up. It's just basically a spinning PCB here that you spin as like one of those tabletop things. So you spin it and then lights rotate. So it should be, I think, a fairly simple circuit. However, if you've watched my last videos, you would know that the plan for me is basically I'm trying to prepare for my final year project by learning the basics of how, general PCB kits work. Because what I want to do is I want to actually, in my final year project, I want to build some DIY kits like this that I designed myself. So it's obviously good practice for me to go through and do these myself. So I got this off Aliexpress. I've got the thing up here. I paid $1.70 for it, so that's like, plus $1 shipping, so just under $3, so probably about £2 I paid for it. I'm not entirely sure how it works yet, but what we'll do is in this video, firstly obviously just unbox it, and then I'll solder it all together. And once we've soldered it together and seen it work in real life, then what I'll actually do is I'll actually put it up on the simulation software, simulate the whole thing, and figure out in detail what each component is doing. And I think that's far more important than just if I just build it. I don't learn much from just soldering these on, but I'm going to learn a lot more from actually taking the time to run the simulation. So I've got the schematic here, so it should be fairly easy to simulate. I've got all of the values of all the components. So after we've simulated the software, I would actually like to apply some modifications to the circuit as well. So yeah, that's the plan. Just briefly, I also noticed that basically it doesn't come with any batteries. So here's where the battery is going to go like that, or the battery case is going to go like that, and you need to basically put a battery in there. So thankfully I had two of these spare, but make sure if you're going to buy the kit, you need to buy the battery separate. So you need these CR2032s, CR2032 3-volt batteries. If you just Google that, CR2032, you'll be able to get them, and these are the two batteries that I need. So we should be able to actually test if the LEDs are working using the battery. Nope. No. Alright, well. Okay, it's not turning on. That's fine. Okay, let's hope it works anyways. If not, I need to buy new batteries, but I haven't used these batteries, so they should work. Okay, just quickly, I'm just going to take a look at the official description as well. So we've got here, the circuit consists of a triode. So I know that the triode is this thing here that looks like a transistor. There you go. So that's the triode. So the circuit consists of a triode composed of a multi-vibrator, which is this. The vibrator, right? So multi-vibrator of two to drive two groups of LEDs flashing alternately. When connected to the rotating LED gyro, the vibration switch is connected to the power supply. The circuit works because the temporary phenomenon of eye, vision, and pattern appears. So obviously it's not written in English, it's written in Chinese or something, and they've translated it. So it's a bit tricky, but okay. When the battery is loaded, the shock switch S1, so if we look at our schematic here, S1, this switch up here, is disconnected. Okay, so once the battery's in, this is disconnected. So the circuit does not work because it's the power source. These are the LEDs, right? Over here, okay. When the gyro is rotated, due to the centrifugal effect, the vibration switch S1. So this is a vibration switch. So when it detects vibration, that's when it closes. Interesting. The vibration switch S1 is connected and the circuit works. The working principle of the multi-vibrator circuit is that when the power is connected, the two audions Q1 and Q2, Q1 here and here, so these are like transistors. I assume this is these two, Q1 and Q2. They've called them audions, I don't know what those are. Will contend for the pilot. Okay. but because of the difference of components, only one tube is the most pilot. It's English. Then the two transistors in the circuit will take turns on and off, and the two light emitting diodes will keep circulating light. When the top is rotated, the bright LED will appear in a straight line because the lights are staggered, and each two lights are lit alternately, so there are multiple dotted line shape patterns. Okay, and that's it. So we've got a ceramic chip capacitance, 2 of them, 4 1K resistors, 2 1K resistors, 2 triodes, a battery holder, 2 of them, 4 3mm LEDs, and then some screws, a vibrating switch, and a circuit board. Cool. So I've got 2 batteries here. So let's just start soldering it together. Shouldn't be too tricky, should it? I don't think so. I haven't soldered in a month or two, so forgive me. Alright, so I've tinned my soldering iron, put some flux, and then what we're going to do first. So we're going to do all the resistors. Okay, so interestingly, just as I was doing that, I realized that basically if you look on the PCB here, you can see it says 1M, 1K, 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 1M. So it seems like R4 and R3 need to be 1 mega ohms and not 1 kilo ohms. And you can see the same here as well on this R3 and R4 1 mega ohms. But yet on the component listing on the website, it says both 1K, 1K. And I thought that was a bit weird. Why wouldn't it not just put 1K 6 resistors? So I think, yeah, I need to just remove this R3 from here. And this is going to go into the R6. There we go. So these are our 4 1K resistors. I've put them in the wrong way, basically. I made my life hard for myself. And then I'll just put the 1 mega ohm resistors in there. So yeah, just be aware of that. The 1K ones go there, and then 1 mega ohm ones go above it. It's written on the PCB, thankfully. Alright, so not the best. One of those resistors is sticking up a fair bit, but it's fine. I'm going to move on. So let's just cut this off. I actually recently didn't put these snippings in the bin and then stepped on it and pushed it through my foot. So yeah. Put your clippings in the bin. I've now got a bin right next to me, so hopefully that won't happen again. I've got kids as well. I'd hate for one of them to step on it. Cool. Alright, so that's the resistors done, and then we've got some diodes. It's D1, D2, D3, D4. So those are just the LEDs, right? The positive and negative is a bit confusing. I think it means positive is on the top. Yeah, I think so. Anyways, this is why I do these basic circuits, because I struggle with just basic things like soldering. Put some flux here. Okay. Right, so hopefully that's done. So same again. Alright, so we've got 2 capacitors next. I don't think polarity matters here. Just values 104 and 104. So they're both the same values. So that's fine. Just try and do this with my hand. Okay, so not the best, but that's done. And then we got these, what do they call them? Triode, diode things. What's it called? Triode. So I think polarity does matter, but it appears that they're the exact same chip. So thankfully I've done it the right way in terms of height, which has worked out well for me. These should be hopefully easier to put in, I think. Cool. Alright, there we go. And I think I just need to put this vibrator thing in now, and then the battery clips. Okay, so this multi-vibrator, don't know if it has polarity. It looks like it does have polarity. Oh man, I'm not a fan of soldering at all, but I kind of just see it as a necessary evil. Almost burnt my finger there. Ah, crap, I actually did burn myself. Okay. I didn't catch those, so those are flowing off into the ether. Hopefully they come back safe and sound. Alright, we've got these little caps. For the battery. I love it, the fact that even you have to assemble the caps yourself. I look forward to designing my own PCs. I think that's going to be amazing fun. I really look forward to it. I'm actually, to be honest with you, I just finished my second year, and I'm really looking forward to third year. I've got 4 months of summer, and then after that, I'm going to go crazy. I'm going to have some time off summer, but then I'd also like to get started on my final year project. Alright, I had to put a fair bit of blob on there, but I believe they're on. So I don't think we're missing anything else now. Let's try and... Okay, well, we'll do this. Let's do this. I don't know how to do this spinny thing. Alright, good to have solder right now. If I'm not mistaken, I've got to put this little gold thing into this big silver thing, or silver nut. Okay, so then put that through there, and then screw this on. Based on the pictures, that's what I'm understanding. Cool. That's cool. Okay, so let's put the batteries in. Oh, my thing's popped out. Damn, I really did not put enough solder at all. Did I not? I think I forgot. I didn't put any, yeah, I forgot. I just did those two. I didn't do the middle ones. That's fine. There we go. Alright, so now, hopefully, batteries in. This way. One there. One there. Okay, so put the two batteries in there, and then for now, nothing's working. If I spin it, I can't see anything working. Yeah, nothing. It's not working. I'm not sure if maybe it might. I think it might be the batteries, because the battery didn't light the LED, which was concerning to me. I don't have other batteries, so I need to probably purchase some batteries. So these are supposed to be 3 volts, right? So let me just check the voltage, because when I tried to test the LED, it didn't turn on. It says there's a 0.7 volt difference. That's a bit concerning. This isn't a transistor. Yeah, look at that, just 0.7 volts, man. It's supposed to be a 3-volt battery. 2.5, okay. Okay, so one of my batteries is a dud. So one's showing 2.5 volts, which I think would be good enough. This one here is showing 0.7 volts. On the off chance, do I have another one? It's like my pot of batteries. 2052. I think it's 16, yeah. I need 2032. 2016. Let's try this 2025. I don't see it working personally, but oh, look at that, it worked. Even with the smaller battery. Alright, let me turn off some lights. That's cool. It reminds me of a Beyblade. I like it. So I wonder if, for example, you see, as I spin it like this, it doesn't turn on, right? Can you see? Look, so it's going slowly, but not turning on. I'm wondering if like these resistor values have anything to do with whether or not it works, because it works at a certain speed. I'm thinking the sensitivity is going to be controlled by something. Oops. Yeah, I'm thinking the sensitivity is going to be controlled by something. It actually reminds me of a Beyblade. This is amazing. Alright, let's stick this in a simulation and figure out what each of these different components do. I'm guessing right now that these resistors are going to have something to do with so the 1K resistors are probably just for the LEDs, just to keep them safe. So it's probably going to be the R3 and R4 capacitors to smooth stuff out, right? So 1M is to base. Yeah, I think it's going to be the 1 mega ohms that's making a difference, I think. But I like it. I love how it's interesting how. Oh, I understand what's happening. I get it now. So there's obviously just 4 LEDs here, but they're turning on and off at a different. They're alternating. So when one's on, the other one's off. That's brilliant. I love it. Cool. All right, let's run some simulations. Okay, so here's the schematic which we got off of Aliexpress. Now, I've tried to simulate it, but it's been quite challenging. Firstly, I've had a challenge with the ground, so I've put the ground here, but on the schematic there's no ground. I'm assuming, from what I know about electronics, that this point here is going to be a lower voltage potential than up here, right? So it makes sense to me to put the ground here, which is what I've done. However, I find it challenging when it comes to, for example, putting the triodes in. I'm not sure how they differ to transistors. I couldn't find a triode inside multisim, so I've had to just go with transistors. But when I run the simulation, I can't get it to work. So unfortunately, I'm not able to. The way that I would learn how this works is I'd play around with things and see what difference it makes. And I haven't been able to do that. So I'm not really able to understand, for example, when you've got these two 1 mega ohm resistors here, the R3 and R4, I find it challenging to figure out what they're doing. If I have a look here, so the resistor is going and to the base of the transistor. Yeah, I assume it's to just put a low base current to activate the transistor when the switch is pressed. Yeah, it's challenging. I don't really understand what's going on here. So what I'm going to do is, since I can't mess about with the simulation, because when I run the simulation it throws up an error, I'm going to try and mess about with the actual circuit itself on the board. So it might mean that I might damage some things, the price I'm going to have to pay. But I'd like to, for example, try and swap out these LEDs for normal LEDs, see what I can do there, and try and change these 1 mega ohm resistors and these 1 kilo ohm resistors, change them and see what impact that has on the circuit, so I can figure out what's going on with what. So yeah, that's the plan. Let's jump back to the actual circuit and try and figure out what's going on. If you understand this circuit, please leave a comment, let me know. It's like I said, I'm doing this as a learning process for myself, so if you can help me out, be very, very grateful. All right, so we're back on this now. You can see it's still working. So let's try and figure out kind of how this works by taking it apart. So obviously this is the vibration switch, right? So when it detects the spin, then the switch closes and that's when the lights turn on. So I should be able to just short these out. If I just put cable along here, if I can do it, it's a bit tricky. There you go. So you can see there that it lights up. Interestingly, it looks like only 3 of the LEDs are working. Red, yellow and green. That one there, that D1 isn't working. Let's see if I can notice it in the spin. Yeah, possibly. I mean, let's just have a look at the video. Yeah, so the video has 4 layers of lights. Yeah, so definitely this D1 here should be working. It looks like it's this resistor here. This R1. Maybe D1's damaged because I tried to test it with the battery. Maybe I blew it. If I blew it, then I wonder how to test that. I'm not sure. I'm thinking perhaps a diode test. If I test all of them. Alright, 2.4, 2.1, 1.8, 1.8. So this should be lighting up the LEDs. I didn't see them light up, but let's just test it out again. So okay, there you go. That lit up as well. That lit up. And this last one's not lighting up. Is it reverse polarized? Let's see. No, I think it's just dead. Sorry about the noise. It's too hot so I've got the window open and some loud motorbike. Alright, let's try and replace this LED then, see if we can get this working. So it's just this D1 here, back on the soldering iron. Probably should leave this in here actually. Alright, so it's this one here. Alright, I'm struggling here. Need to probably push them both at the same time. That LED is boiling, man. If it wasn't dead before, I think it's dead now. Alright. Oh yeah, wow, look, it's fully cracked open. Okay, so that LED is toast. Oh, I can't really get it out. Alright, let me try and use my suction thing. I really don't have good soldering skills at all. I can't do it, man. I always burn myself when I'm changing hands with the soldering iron as well. Alright, let's try and stick this back in here. Nope. Even my iron's not hot enough, but I feel like it is. I feel like my iron's too hot. Maybe I need to replace the tip. And this is where I think it might be worth spending the money to get a better soldering iron. At the moment, I'm not getting anything off. Come on, man. Okay, here we go. Ah. Yeah. Let me try a wick, although I've had no success with wick in the past. So what's this? Resoldering wire? Yeah, this is the wick, right? Yeah. Yeah, I've had no success with solder wick in the past, so the thing is, you think like, you know, 2 years of electrical engineering, you'd know how to solder, but nope. Alright. Like I said, literally getting nowhere. Oh, interesting. I didn't even notice, but it fell off. So I've just got, alright. Let's try and pull, maybe cut this off, I think. Maybe might be the best route. Oh wow, you see that? I shorted out from the battery to here. That's funny. Okay, so let's try a different LED. We'll go with a yellow one. Now, how do I go about putting this in when I've got all of this solder here? I think heat it up and push it in. It's going to be tricky to do. If you have any tips, please leave them below, because, you know, I really would like to get better at this. You see the struggles that you go through when you're just trying to self-teach yourself all this stuff. But this is the thing, this is how I want to learn, instead of learning on my final year project. Because imagine if I've just paid for an expensive PCB. It just immediately reheats, man. I need to stick the soldering iron on underneath here. No, I'm not. Yeah, I'm not able to get this solder off. So yeah, I don't know. I'm a bit lost here. I feel like maybe I should be doing this with the batteries out. So let's just remove the batteries first. I feel like mixing heat and batteries is not a good idea. Alright, bear with, let me just go off camera and just try for the next 45 minutes to get rid of this bloody solder. Woohoo, success. Okay, so I managed to get it off using this lovely solder wick. It took me only about 10 minutes, to be honest with you, but I got there in the end, thankfully. Oh man, so frustrating. So now we need to stick these in. Okay, kind of squeeze that in, and then just short these two out. There we go. Wait, is it lighting up? I don't know. Alright, it's kind of lighting up. Let's go with a lower voltage LED. Let's go with a red one. So still not that bright. Thinking I may need to reduce the resistor on here. So let's do that. Let's solder on this LED. There wouldn't really be enough space for 4 of these big ones. Yeah, let's solder in this LED. Oh, you can see the red in the middle. That actually looks quite cool, the fact that it's bigger. Ah, crap. I need to make this like probably 3D print a case for it or something. I gave it to my kids for about 10 minutes. I was surprised to see it was still working. Yeah, so I like it. I would just like to make No, to be honest, that's actually kind of bright enough, isn't it? I think from the top it looks bright. It doesn't look as bright when you look at it from the side on view, but from the top it looks alright. Yeah, I think let's reduce the values of what R1. Let's just check the schematic quickly. We'll reduce the values of. So we'll reduce the values of R1, R2, R4, and no, sorry, R1, R2, R5, and R6. R1, R2, R5, R6. Let's take it down to, so we're at 1 kilo ohms. We'll take it down to 330 ohms. Alright, so I've got a 330 ohm resistor here. I'm just gonna be replacing just R1 because that's the resistor for the red LED, and let's see how bright it gets. And then I might do the others as well. So R1 is the second. Usually I can push it out, but now it doesn't seem to be. None of this stuff is complying. Oh, almost burnt out an LED. Okay. This is probably not worth it because I think I'm going to struggle again to get. I think I'm going to struggle again to get this bloody solder off. Right, that actually kind of worked. Nope. Ah, dear. I'm now starting to burn the PCB, which is not good. Once that gets burnt, this ain't gonna work. Alright, I think I should abandon ship here. I don't think, for whatever reason, I'm having big soldering problems. Now, I have some spare tips, which maybe I should use. Just obviously don't change your tip when the soldering iron is hot. I have to wait a while for it to cool down. I'm always like, yeah, you know what, this will be easy. Just quickly replace the resistor. But man, it's not. Right. Is it still working? Alright, it's still working. That's actually super bright. Yeah, so it's still working. I think. Ah, man. I cannot be. I'm having just no success getting them out. I think I'll change the tip to a new one, and then it might be time. Maybe use a bigger tip actually. It might be time for me to buy a much higher quality soldering iron. I don't know, or better tips. I'm not sure. Let me know what you think. My soldering iron is this one here, Hanmatech. The tip is, yeah. I mean that's kind of burnt, isn't it? But I don't know. I dip it in this. You know, I clean it here. Like, why is it that? Is it? I don't know. Is it possibly the PCB? I don't know. Why is it so difficult to get the resistor out? I mean, I could cut it and then maybe just short. If I cut it and then short the wires out, but that's the resistor there, and you can see I've kind of burnt the PCB a bit. I'm gonna keep trying, I think, because I don't want to give up, and obviously, like I said, I want to try and learn. So if I do burn the PCB, you know, hopefully I learn from that. So let me just wait for the soldering iron to cool down, and then I'll carry on. Alright, so I've swapped out my bit for a much larger bit. Ah, man, I forgot it was on. Oh man, what do I do with that? 1 second. Just wash it and wax some Vaseline on. So I've noticed that this stuff happens a lot because I'm talking, I'm not focusing on what I'm doing, and it's a big problem. So whenever I'm doing something dangerous, I try to turn off the recording or at least not talk. But yeah, this is the new bit that I'm using. Ah, man. It's funny, I upgrade to the bigger bit and burn myself with the larger one. It actually kills. You know what? It didn't hurt like up until just now. Anyways, so this is the old bit versus another new bit that I've got. So yeah, I don't know if that makes a difference, the burn and stuff, but yeah, let's try and use this new one. This is not worth this bloody gyro thing. Anyways, let's try and... Oh man, it's actually picking up in pain. Might need a paracetamol. I'm trying to just heat the thing up and then push it out, which is what I normally do. And that's actually gone. That's worked, which is nice. Yeah, I can't get it. I can't really get it out. Yeah, let's try and wiggle that out now. Yeah, I really don't know what to do, to be honest with you. I can't, for whatever reason, I don't know how to get these components out. Is it an experience thing? Is there a technique I'm missing? Is there a tool that I'm not using? Because I feel like I need free hands to do this. Let me know if you know something that I could use. Yeah, I don't even know what to do right now. I think possibly the best bet is to just cut it, because this is too much time to be spent on just, you know, one bloody resistor, man. How do you get better at this stuff? Is it just practice makes perfect, or is there some sort of, you know, course or something that I need to... I don't even know how, man. I'm sure it's just practice makes perfect, but I haven't really struggled with this kind of thing. Okay, I didn't want to whack up my soldering iron, but I'm just gonna put it up to max, and then I'm thinking it's possibly just the heat issue. There's not enough heat. Okay, I can see myself burn. I can see the PCB burning now. Alright, how do I hold this in place without touching it? I'm sure I'm gonna burn myself again. Oh dear. Alright. I don't know if that's enough. Just gonna try some more. I've watched Lewis Rossman do this, you know, hundreds of times. And it just goes to show that, you know, watching doesn't mean jack. Especially because, you know, I'm using cheap, you know, solder, cheap flux, and cheap soldering iron, cheap solder wick. So when you're watching him do it, and if he's using expensive stuff, I'm assuming that makes a difference. Alright, I think that's kind of stuck down, interestingly enough. Yeah, look at that. I think that's done. I'm a bit reluctant to touch it. Seems like something's still there. I've got something on the tip of my... There's like some remnants there. I don't think I'm going to be able to get an LED or a resistor in there. Let's just try. Definitely not. And I can't even see it on this side. Wait, actually, technically I could put a resistor on the underside, right? Should I just try that? Don't think it's going to be able to. No, okay. What other techniques can I use to make this hole? I mean, a drill possibly. I don't know if I have a drill bit small enough for that. What else can I use? Yeah, I'm really stuck here. Alright guys, so it's this is an RIP for me. I'm done sadly. It's bloody hot. I just used the heat gun on it to try and get the metal piece out there. It still didn't come out. I ended up burning away the PCB here, and yeah, I'm gonna call this quits. I just think I wonder if it's still gonna work. Let's try it. The PCB is still very hot. But yeah, no, this is a done one for me. Yeah, I need to get better at soldering, but trying to get out, you know, a bit of resistor. Okay, it still works. That's amazing. I did not expect that at all. But yeah, the other LED that I put in, it came out as I was heating up everything. So yeah, cool. Alright guys, thanks for watching. I need to get a lot better at this stuff, obviously, and so I'm gonna keep doing them. You know, you win some, you lose some, as long as the outcome's income. Take care, guys.